So in this tutorial, we're going to talk a little bit about how to prepare a model for an augmented reality experience. So I've got a sketch that's set up here. It's a 4 meter by 4 meter or so model of a double curving surface with some pattern on it. It's been produced in Rhino, so the underlying surface is a sub-D model, and then we've got a whole lot of these little NURBS planar surfaces describing the pattern. And you could stream this to Fologram or publish this to TwinBuild, no problem, but you're not going to get the optimal visual experience for using this as a fabrication guide out of the box. And there are certainly some things that you can do to prepare this model to improve the experience for end users and ensure that you're actually getting the most out of the mixed reality fabrication process. So the first thing to consider is the amount of detail in the model. So in this model, we've got several thousand NURBS objects, 5,866 surfaces in this case, which will all be meshed before they're sent to the HoloLens or published with TwinBuild. If we run the mesh command, if we run the render mesh command, show render mesh, we can see how detailed the render mesh will be for each one of these circles. So this is the default Rhino render mesh, which will be used to stream this object to Fologram or publish it to TwinBuild. And each one of these circles is creating a fairly detailed render mesh, quite a few vertices and faces, certainly more than would be needed for using the circle as a guide for laying out this particular pattern. So if you are working with many NURBS objects, as is the case here, it's important to think about how we can reduce the amount of detail in the model that's being streamed to the HoloLens or published to TwinBuild. One way that we can reduce the amount of detail in the model is to manually mesh any detailed NURBS objects in the model and join those meshes together. So I'm going to select all of these NURBS circles, and I'm going to run the mesh command just with as few polygons as possible. And this is going through and making a 13-point mesh with 11 polygons for each one of these 5,000 or so circles. Once this command finishes, we can then join all of the resulting meshes together into a single mesh. So we only have a single draw call on the HoloLens, and this is going to be significantly more performant than trying to render every single one of those individual circles. You can also do this parametrically with things like Grasshopper, which will give you even more control over how you're meshing these objects. For instance, you might duplicate the edges of the circles and construct an even lower polygon mesh from each of those. Okay, so it looks like that command is now finished. So I'm going to grab those meshes and join those together into one single mesh. And we've now got a mesh which is 64,000 faces and 76,000 vertices, which is going to work fine on most mobile devices or the HoloLens. Good practice is to put this mesh on a new layer, and then we can hide the original NURBS layer so that won't be published. You might also find that in some cases it's more convenient to have a surface model. It's more convenient to have just a line work model of whatever it is that you're trying to produce on the HoloLens than it is to have a surface model. And this is because surface models are going to occlude any physical objects in your environment. So if the goal is to reproduce this pattern with a number of little circular plates, it could be quite distracting for the end user to be locating a physical plate which is hidden by the holographic plate. If this is the case, it can be useful to just render each one of these objects as line work, which is also possible by duplicating edges in Rhino. So we can get some of these circles, for instance. Generally speaking, I wouldn't recommend trying to convert all of these circles to edges all at once, just because you may end up swapping one problem with another where you're creating a huge amount of curve geometry rather than surface geometry. But to demonstrate how this works, you can select the objects that you want to extract edges from. Run the duplicate edge command to select any edges that we want to duplicate. I'm going to unselect the sub-D model here for a second. Move those objects onto a new layer, hide the original layer, and then we have curves as a description of our pattern rather than solid surfaces. These curves in Fologram and in TwinBuild, they're going to be rebuilt as simpler objects just to reduce the detail in the model on the that's rendered on the HoloLens or on your mobile phone. So you may need to customize the settings to ensure that the number of vertices in these curves that's being streamed to your device is sufficient for performing the task. Usually the defaults are going to be okay. When fabricating larger surfaces like this as well, you run into the exactly the same issue where the surface of the hologram will occlude any physical surfaces beneath it. So if the goal is to fabricate this complex double curved object using a holographic guide, it's almost always going to be more useful to render just the edges of the object on the HoloLens than it is to show the surface, or at the very least to show the edges as well as a very transparent surface underlying it so that you can still see the physical object as well as the virtual object that you're building. You can use the dupe edge command to select edges in your model that you want to duplicate. So I've duplicated those now, and then we can adjust the materiality of the surface just using the materials in Rhino. So I'll assign a custom material to this surface with a large amount of transparency, and we'll just leave it as a white color for now. Might make this 90% transparent. Then that transparent object is going to appear beneath the curves, and we'll be able to see both the curves describing this geometry and the underlying surface. If you need to create more curves in the model, you may need to convert your object to a different type of geometry like a mesh and then extract mesh edges from that. When you're working with complex NURBS objects, as is often the case with Rhino, so I'm going to convert this to NURBS just to create an example. So say a polysurface like this one. It's also important to ensure that Rhino isn't creating a very, very detailed render mesh that's being sent to the HoloLens. So depending on the amount of detail in your polysurfaces in Rhino, the render mesh may also be extremely detailed. Again, you can use the show render mesh command to preview what that render mesh is going to look like. In this case, the render mesh looks okay. But as a good rule of thumb, if you're experiencing like very low frame rates on the HoloLens, oops, let's hide that render mesh. You can create your own custom mesh of your object using the mesh command, and just set your desired polygon count to reduce the number of mesh faces in that model. If you're creating a fabrication sequence from your model, so in this case, I'll just use this as an example as well. Perhaps we're going to fabricate each one of these individual surfaces in a sequence one by one. You can use the layers in your model to create that sequence. So rather than having all of these objects on one layer, if we put these on individual layers or sub layers, so let's create a layer called panels, and then we can create new sublayers for each object and move these objects onto these layers. Then you can create task sequences that you'll be able to step through in Fologram or in TwinBuild using the layers panel on your HoloLens or mobile device. So using layers is a good way to essentially be able to show individual objects one at a time. So if we select this layer and we turn off the other layers, on your mobile or HoloLens device, you'll be able to show just this individual object one at a time, which just reduces the amount of information that's being rendered on the HoloLens, making this easier to follow for an end user. The next thing to consider is where your model is located in physical space. So it's really important when you're creating mixed reality experiences to keep your model located at the origin where possible, just because this means that when the model is loaded up for the first time for the end user, it'll appear right in front of them rather than far off in the distance or at some unexpected location. So if, for instance, we were going to use this model here where we'd set up our curves, and that was going to be our fabrication guide, we would want to create a new Rhino file. I'm going to hide all of this content and just make sure that that model is centered on the origin to make it easier to find and align for an end user. Good practice is also to keep the model aligned with the Rhino. I'm just going to turn on near snaps here, X and Y axes where possible, or just keep this as intuitive as you can, as this is also going to make it slightly easier to set out in your workspace. So keep models oriented at the origin and aligned to your Rhino axes where possible, especially with Fologram. This will make it easier to set out using the Fologram QR code. With TwinBuild, it's not going to be so challenging. You'll need to locate your model specifically relative to your the markers that you've set up in your workspace. Okay, that pretty much goes through everything that we need to know for preparing models for mixed reality. Joining objects, meshing objects where necessary, keeping objects at the origin, using line work and curves where possible, adjusting materiality to ensure that objects are always visible, and tweaking model locations and files so that they're aligned with the origin.